So my project is quantifying trust in online social networks. So trust plays a central role in our lives and it's found in many different disciplines. And here are just some examples. It's found in economics, psychology, sociology, computer science, political science, and trust has many different definitions depending on the domain. So here are just a couple of relevant definitions of trust for the project. So trust is a factor in human decision making, and trust is a measurable level of risk. So in general, trust is a belief that the truster believes that the truster can be trusted for a specific goal in a specific context. So recommendation systems can use trust. So in general, recommendation systems filter through information and then make personalized suggestions for users. And these systems can exploit trust relationships to improve predictions. And these are trust-based recommendation systems. So an important question for these systems is, does user A, who is not connected to user B, trust user B? And these systems, the trust-based systems, use a trusted graph as input. So the problem formulation for my project, the input is a social network graph and the output is a trusted graph, which the recommendation system can then use. So the main question is, how can this trusted graph be generated? And this boils down to the question, well, how can we quantify trust? So here are just some existing papers that aim to quantify trust. So the first is the SW Trust Framework, and this framework leverages domain information and weak ties, and then generates small trusted graphs. So domain is defined as a unit where members share specific interests, and node A trusts node B if B is related to the topic and A's neighbors are related to B's neighbors. So it uses domain information and structural information. And then after creating the trusted network, it selects shortest trusted paths, and that creates the finalized trusted network. So on the left, it shows the initial trusted network created from the domain information and weak ties. And on the right, it shows the final trusted network after using breadth first search to select the shortest trusted paths. But since this framework relies heavily on domain information, it is limited to data sets that have this information. And the graphs are also source and sink specific. So for each different pair of source and sink, a different trusted graph would be generated. So the second is a user interaction and sentiment analysis algorithm. So the authors create a user interaction graph and then apply sentiment analysis to the content of those interactions. So the paper focuses just on Twitter data. So here the user interactions are all Twitter specific. So they include mentions, retweets, and likes. And the interactions are given weights. So the more recent interactions are more significant. And so this algorithm is good for dynamic data. So when more user interactions are added, the trusted graph is basically regenerated. And then the edges are assigned a positive, neutral, or negative score, depending on the sentiment of the interactions. And the third is the conversation metrics algorithm. So this algorithm uses communication data that has the sender, receiver, and time of that communication. And the authors define trust as frequent, long, and balanced conversations. So they use timing to create disjoint sets of conversations from the messages that are exchanged between two users. And then they use these conversations to calculate trust. So for my project, I combined existing methods and also just general ideas from the existing literature to create two new methods. And the new methods include a statistical component combined with sentiment analysis. And to evaluate the trusted graphs that these methods generate, I evaluated the similarity between the graph and a proxy for trust. So the data I used is Twitter data taken from June and July 2009. The tweets include mentions where a user directly replies to another user. It includes quote retweets, which essentially includes the phrase RT and then has a copy and paste of a tweet from another user, and also includes the username of that user. And then it also includes hashtags, which are used when a user is talking about a specific topic. So I only included tweets with mentions because I wanted to create a communication network, and I only included tweets with ASCII characters for the sentiment analysis portion of the algorithms. So after this, there were 6,493,619 total tweets. And for multiple mentions where a user is replying to more than one person in one tweet, an edge is created for each mention. So on the right is an example of what the data looks like. So it includes the time of the tweet, it includes the user who sent the tweet, and it also includes the content of the tweet. And the content includes the receiver. So on the bottom is an example of an adjacent pair of nodes in the communication network. So each user represents, each user is a node, and there is an undirected edge between the nodes if there was a tweet exchanged between them. And the edge contains the content of the tweet, and it also contains the time of the tweet. And so this graph has 2,438,080 nodes and 5,760,277 edges. So the first method uses the conversation metrics algorithm that was described earlier, and also sentiment analysis. So first, a new conversation network is created that doesn't include any retweets for the evaluation part of the method. And for each pair of adjacent nodes where the number of messages exchanged is greater or equal to 2, the set of k messages, m, is first sorted by time. And the average time is defined between messages is defined as the time of the last message minus the time of the first message divided by the total number of messages. And then M is divided into disjoint sets of conversations where two sequential messages are put into the same conversation if the time between them is less than or equal to the average time between messages. And then an entropy equation is used to calculate trust to measure the balance of the conversation. So the P here is the percentage of messages that are sent by one user in a specific conversation. And then trust is calculated using this equation here, TUV, and it essentially, for each conversation, multiplies the magnitude of that conversation to the entropy equation for that conversation, and it sums up that value for all of the conversations. And then this trust calculation is the weight of the edge in the graph. And then the weights are normalized for the entire network. And then sentiment analysis is applied for all of the messages exchanged between a pair of nodes. And if these messages have mostly a negative sentiment, then the edge is removed from the graph. So the second method uses the idea of domains from SW Trust and then also applies sentiment analysis. So first, a new domain graph is created that doesn't include any retweets. And each tweet also has at least one hashtag. So here, a hashtag is equivalent to a domain. So then a list of all unique hashtags in the graph are created, and the trusted graph is then generated. So if a pair of adjacent nodes have exchanged messages and also share a common domain, then they're included in the trusted graph. And for each pair of adjacent nodes in this trusted graph, sentiment analysis is applied for each message. And again, if the majority of the messages have a negative sentiment, then that edge is removed from the graph. So the sentiment analysis model I used is a binary classifier, and it predicts whether the content of the tweet is positive or negative. So it first pre-processes the content and removes punctuation, stop words, and strange symbols. And it then lemmatizes the words. So it basically returns the base form of the word. It transforms the strings into token integer counts and then transforms those token integer counts to TF-IDF scores, which represent the relevancy of the word to the entire collection of tweets. And then the TF-IDF vectors are trained on using a multinomial naive Bayes classifier. So this model was trained on 27,155 labeled tweets, and it had an accuracy of about 94%. So to evaluate the trusted graphs, I created a network that represents a proxy for trust, and this is the retweet network. So it's assumed that if user A retweets user B, then user A trusts user B. And then I compared the trusted graphs node and edge sets to the retweet network. And a high percentage of similarity would mean that the trusted graph captures trust. And then I also created random graphs for each trusted graph to determine the significance of that similarity percentage. So I chose a random set of nodes from the original network used to create that trusted graph, and then added the edges from that same network. So here is a table of my results. So the conversation trusted graph has a higher percentage of similarity to the retweet graph than the conversation random graph. So that similarity is significant. And similarly, the domain trusted graph has a higher percentage of similarity than the domain random graph. So that percentage is also significant. And then comparing the two methods, the conversation metrics and sentiment analysis method, with the domain metrics and sentiment analysis method, the domain trusted graph has a higher percentage of similarity, so it captures trust a bit better than the conversation trusted graph does. And then I also compared the conversation metrics and sentiment analysis algorithm to the conversation metrics algorithm without adding any sentiment analysis. And these methods performed the same. So they outputted the same trusted graph. So applying sentiment analysis didn't change the output. And these are the sources I used. And thank you for watching.